In this video, I'm going to demonstrate our final Excel project for the semester, how to price and amortize bonds. As we talked about in class, bonds are debt instruments. A company that issues a bond is borrowing money, and any investor that purchases a bond is actually lending money to the issuing company. Now, as with any debt instrument, a borrower has an option to repay both the principal and the contractual interest, while the lender has a right to receive back both the principal and the contractual interest. Now, let's go over some terminologies about a bond. First, we're going to talk about the par value. The par value is the amount to be repaid by the borrower at maturity. For corporate bonds, the par value is usually $1,000 per bond. The stated rate or coupon rate is decided by the issuer when the bond is issued, and it determines how much cash is paid by the borrower to the lender each period until maturity. Most corporate bonds will pay that stated or coupon rate on a semi-annual basis. So the entire year's interest is paid in 2 installments. And finally, the issuing company will set a maturity date, the date when all principal and interest is repaid by the borrower to the lender. The bond is worthless after the maturity date. Now, let's determine the cash flows of a bond. The cash flows is how much cash the borrower has to pay and how much cash the lender has a right to receive. A company issuing a bond must pay the par value multiplied by the stated rate multiplied by 1/2. Again, this is for semi-annual bonds, so the year's interest is paid in 2 installments, so 1/2 is paid in each installment every 6 months until maturity, plus a one-time payment of the par value at maturity date. So let's get an example of this so we understand what's going on. In the example from your book, a company is going to issue bonds with a total face value of $100,000. So the company issued 100 bonds that each have a face value of $1,000. The bonds have a stated rate of 7%, which is payable semi-annual, with a 10-year maturity. So, with those terms, the issuing company must pay, and the lender has a right to receive, $100,000, the par value, multiplied by 0.07, multiplied by 1/2, which is $3,500 every 6 months until the maturity date, plus a one-time payment of $100,000 at maturity date. So this is just how bonds work. Now let's talk about a couple of important things before we go and price and amortize this bond. So bonds are negotiable. The bond can be sold at any time to anybody at any price. So somebody can pay $1 for this bond. Even if somebody pays $1 for this bond, they will still get $3,500 every 6 months until maturity, plus $100,000 at maturity. It's also possible that somebody who doesn't understand these bonds might pay $1 million for this bond, but it doesn't matter what you pay. You're still only entitled to $3,500 every 6 months until maturity, plus a one-time payment of $100,000 at maturity date. At that point, the loan is repaid. So, as I said before, the selling price does not affect the amount of money that is going to be paid by the borrower. Now, the market price of the bond will change over time depending upon the difference between market and stated rates. This particular bond at 7%, in some economies a 7% return can be good, and in some other economies a 7% return can be bad. So the price of the bond will actually fluctuate over time depending what happens to the market interest rate. So how do we determine the market price of the bond? The market price of the bond is the present value of the cash flows the company must pay, discounted at the market rate. The market rate is the interest that the investor would like to earn. So now let's go into some examples of how to price a bond at a premium, a bond at a discount, and a bond at par value. Now let's talk about pricing a bond at a premium. So let's first calculate the issue price of a bond that pays semi-annual coupons. We're going to look at a bond that has a face amount of $100,000, a stated rate of 7%, and 10 years to maturity. In this case, the market rate is 6%. So if you could only earn 6% in the market, you would be very interested in a bond that has a 7% rate of return, but you wouldn't be the only one who is interested in that bond. Because the bond becomes desirable, the price will rise until the difference between the price that you pay and the cash that you get back equals the market rate of return, 6%. So first, let's calculate the cash interest payment, which is only dependent on the face amount and the stated rate, not on the market rate. So as I said, every 6 months the company must pay the face amount multiplied by the stated rate multiplied by 1/2 or divided by 2, because the payment is semi-annual. So in this case, the company must pay $3,500 every 6 months to the lender. Now let's calculate the issue price of the bond, which is going to be the present value of the cash payments. What we're going to do is we're going to take the present value of $3,500 every 6 months for 10 years, plus $100,000 at the end of 10 years, all at a market rate of 6%. We can now forget the 7% stated rate, because the 7% stated rate is only used to calculate the cash interest payment, not the issue price of the bond. So to calculate the issue price of the bond, I'm going to click in cell B10. I'm going to click Formulas. In the function library, I'm going to click Financial, and I'm going to find PV for present value. So the interest rate that I'm going to use is the market rate. So instead of typing 6%, I'm actually going to click on cell B7, which will put the 6% in. But remember, I have to divide by 2 because this bond is semi-annual. So I'm just going to /2 and let the computer calculate half of 6%. Now, N per. The borrower is going to have to make 2 payments a year over a 10-year period. So to calculate that, I'm going to click on the number of years to maturity. I'm going to click on cell B5 and then multiply by 2. So the company will have to make 2 payments a year over 10 years. That will be 20 payments total. Now notice when I click on PMT, PMT is the payment made each period and cannot change over the life of the investment. So the issuing company is going to make a $3,500 payment every 6 months. So since that's a payment, I'm going to type a negative sign and then click on the $3,500. Now I'm going to click in the FV box. FV is the future value or a cash balance you want to attain after the last payment is made. Well, after the last payment of $3,500 is made, the issuing company still owes $100,000. So in the FV box, I'm going to type a negative because this is an amount the issuing company has to pay, and click on cell B3, the face amount of the bond. We can now see in the dialog box that the issue price of the bond is $107,000, $107,438.74. So I'm going to click OK to accept this value. And now we're going to go and amortize this bond using the interest rate of amortization. Our interest expense is based on the issue price of the bond and the market rate, not the face amount and the stated rate. Now we're going to calculate the interest expense each period for the issuing company for this bond using the interest method. So notice I have a period 0. This period 0 allows us to copy our period 1 formulas all the way down to period 20. So what I'm going to do is I'm going to click in cell F14, which is the ending carrying value for period 0, and that is going to be the issue price of the bond. So I'm going to type an equal sign and then click on the issue price of the bond. So I'm telling Excel that whatever is in cell B10, whatever is the issue price that I calculated for the bond, I want that same exact value as the ending carrying value for period 0. Now we're going to start our amortization chart. So in cell B15, which is our beginning carrying value for period 1, whatever the ending carrying value is for the previous period, that becomes the beginning carrying value for the next period. So the ending carrying value for period 1 is the beginning carrying value for period 2, and so on. So I'm just going to type an equal sign and click on the ending carrying value for period 0, cell F14. So now, because this is a relative cell reference, I'm telling Excel that whatever is the ending carrying value for the previous period, I want that same carrying value for the beginning period for the next period. Now I'm going to hit Enter to accept the formula. Now we've already calculated our cash interest payment. Our cash interest payment is $3,500 and will not change for the life of the bond. So I'm going to type an equal sign, and instead of just typing the number 3,500, I'm going to click on cell B9. That way, if any of my assumptions change, I know that my amortization chart will be correct. But now if I copy this down, it will move. So what I want to do is I want to make this an absolute cell reference by hitting the F4 key. So my cash interest payment will always point to cell B9, will always point to $3,500 as I copy that cell down column C. Now I'm going to calculate the interest expense. So the interest expense is the beginning carrying value multiplied by the market rate multiplied by 1/2, because period 1 is a 6-month period, 1/2 of a year. So I'm going to tell Excel to take whatever is the beginning carrying value, type an equal sign, click on the beginning carrying value for that period, multiply it by the market rate. So I'm going to click on cell B7, but that has to be an absolute cell reference because once again I want it to always point to cell B7 as I copy that formula down. So before I finish this formula, I'm going to hit my F4 key on the keyboard to turn B7 into an absolute cell reference. Then I'm going to divide that by 2 to calculate my interest expense the first period. So we see that my interest expense is $3,223.16. Now the change in carrying value is going to be the difference between the cash interest payment and the interest expense. So what I'm going to tell Excel to do is to take the interest expense and subtract the cash interest payment. So I'm going to tell Excel, type an equal sign, click on cell D15, type a minus sign, click on cell C15. So I'm going to tell Excel to take the interest expense and subtract the cash interest payment. So notice the carrying value is now going to decrease by $276.84. So what I'm going to tell Excel to do is to take the beginning carrying value for that period and then just add the change in carrying value. So I'm going to tell Excel to take B15 and add E15. Those are all the formulas that I need to complete my amortization chart. And if I've done my amortization chart correctly, the ending carrying value for period 20 should be exactly $100,000, the face amount, which is the amount that the company owes at the end of 10 years. So I'm going to hit enter, and now it's really neat because I can select all of the formulas on row 15, period 1, and then just double click that fill handle in the bottom right hand corner. You know you have it when my fat plus turns into a skinny plus, and I can just double click and notice that my ending carrying value comes down to $100,000 at the end of the 10-year period, and I have calculated my interest expense and my change in carrying value for each 6-month period. So the answer to this problem is, if you purchase this bond for $107,438.74, and in return for that investment, you get 20 cash interest payments of $3,500 every 6 months and $100,000 at maturity, your $107,000 investment will earn you a compound rate of return of 6% each year. Now let's look at a bond at a discount. So we're going to look at the exact same bond, face amount of $100,000, stated rate of 7%, 10 years to maturity, pays a semi-annual coupon, but this time our market rate is 8%. If the market rate is 8%, you would not be interested in a 7% bond, and we would therefore expect the price to fall. This bond will be issued at a discount, meaning less than $100,000. So let's do exactly what we did before. Let's first calculate the cash interest payment. So to calculate the cash interest payment, we're going to type an equal sign. We're going to click on the $100,000 face amount. That is cell B3. We're going to multiply that by the stated rate in cell B4, and then we're going to divide by 2 because we're going to get this in 2 installments each year. So the issuing company will have to pay $3,500 every 6 months for 10 years. Now let's use that cash interest payment to calculate the issue price of the bond. So we're going to once again click Formulas and Financial, and we're going to look for the function that says PV takes the present value of an investment. So for our rate, we're going to click on the market rate and then divide by 2, just like we did before. For N per, we're going to click on the years to maturity and multiply by 2. For PMT, because this is a payment that the company is making, we're going to type a negative sign and click on the $3,500. And then in the FV, the future value box, we're also going to type a negative sign and then click on the $100,000. Notice our answer now is $93,204.84. So we click OK to accept this, and then we're going to amortize the bond the exact same way that we did before. So we're going to click in cell F14 to calculate that ending carrying value, which for period 0 is going to be the issue price of the bond. So I'm going to type an equal sign and then click on cell B10 where I calculated the issue price of the bond. So my ending carrying value at period 0 is going to be the issue price of the bond. So if you remember from our premium calculations, the beginning carrying value is the same as the ending carrying value for the period before. So I'm going to type an equal sign and click on cell F14 to tell Excel that whatever is the ending carrying value for one period, I want that same number as the beginning carrying value for the next period. Now we've already calculated our cash interest payment. It's $3,500. I could type the $3,500 in this cell, or I could do the calculation, but I've already done the calculation. So I'm going to type equals and then click on cell B9, which has the cash interest payment calculation, and then hit my F4 key on my keyboard to turn that into an absolute cell reference. So when I copy that down column C, it will always point to the $3,500 as the cash interest payment. Now I'm going to calculate my interest expense. My interest expense, type an equal sign, click on the beginning carrying value, take my beginning carrying value, multiply that by the market rate, 8%. We're going to hit our F4 key on the keyboard to turn that into an absolute cell reference because we only have 8%. And then we're going to divide by 2 because period 1 is 1/2 of a year. We have 20 periods over 10 years, so each period is 6 months, earning 1/2 of a full year's interest. So my first period's interest expense, $3,728.19. So if you remember from our premium, to calculate the change in carrying value, I'm going to take the interest expense and then subtract the cash interest payment. So this time I'm going to have a positive $228.19 change in carrying value. So then my ending carrying value becomes, type an equal sign, my beginning carrying value, cell B15, and then add the change in carrying value, cell E15. I'm now all done with my amortization chart. All I have to do is copy all the formulas on row 15 all the way down to row 34. And once again, if I've done this correctly, the ending carrying value should exactly equal $100,000. So I'm going to select all of the formulas on row 15 from column B all the way out to column F. I'm going to locate that fill handle on the bottom right-hand corner when my cursor turns into a skinny plus, and then I can just double-click to copy all the formulas down. And as you see, I have a $100,000 ending carrying value at the end of period 20. So the answer to this problem is if you invest $93,204.84, in return, you get 20 cash payments of $3,500 every 6 months for 10 years, and then you get $100,000 back at the end of the 10-year period. Your $93,204.84 investment will return you a rate of return of 8% per year. Now let's see what will happen to the price of a bond if the market rate equals the stated rate. In this example, we still have a face amount of $100,000, a stated rate of 7%, 10 years to maturity, but now our market rate of 7% is equal to the stated rate. So we're going to calculate our cash interest payment the same way we did before. Take an equal sign, take the face amount, cell B3, multiply it by the stated rate, cell B4, and then divide by 2 because it's semi-annual. So our cash interest payment is $3,500 every 6 months. So to calculate the issue price of the bond, we're going to take the present value of the cash flows. So in cell B10, we're going to click on Formulas, Financial, and then scroll down until we find PV. In the rate, we're going to click on the market rate of 7%. Do not click on the stated rate. The market rate goes in the rate. And then we're going to divide by 2 because it's semi-annual. N per is going to be the number of years to maturity multiplied by 2, so we have 20 periods. In the PMT, we're going to type a negative sign because this is a payment the company is making, and then click on the $3,500 cash interest payment in cell B9. And then in our future value, our FV box, we're going to type a negative sign and then click on the $100,000 face amount. So we can see here that the issue price of the bond is exactly $100,000. So now let's amortize this bond the same way that we did before. So our ending carrying value for period 0 is the issue price of the bond. So I'm going to type an equal sign and click on cell B10. In period 1 on row 15 of our amortization chart, the ending carrying value for period 0 is the same as the beginning carrying value for period 1. Our cash interest payment has already been calculated in cell B9, so I'm going to type an equal sign, click on cell B9, and then type my F4 key on my keyboard to turn this into an absolute cell reference. Then in my interest expense, I'm going to take the beginning carrying value equals, click on cell B15, multiply that by the market rate. So click on cell B7 and hit your F4 key on your keyboard and then divide by 2. So you're going to notice that the interest expense is exactly the same as the cash interest payment, but we'll calculate our change in carrying value the same way as the interest expense minus the cash interest payment, D15 minus C15, and then finally our ending carrying value is the beginning carrying value plus the change in carrying value, B15 plus E15. So you're going to see that our carrying value of this bond is going to stay at $100,000 until the end of period 20. So I'm going to select all of the formulas on row 15, B15 to F15, and double-click that fill handle. And you can see that my ending carrying value stays at $100,000. And I have now amortized the bond at a premium, the bond at a discount, and the bond at par.